Hello everyone, this is Abhinav Joshi. I'm a virtualization solutions architect at NetApp. So I'm part of the solutions engineering team that's responsible for developing the best practices and the reference architecture for anything VMware or NetApp storage.
And my name is Larry Touche. Am I on? Okay. My name is Larry Touche. I'm also with NetApp. I'm in the data protection team, and I'm the technical marketing engineer for our storage adapter for the SRM product. And I'm also the technical marketing engineer for our SnapMirror product, which is the replication protocol we use to work with SRM.
Here's the agenda for today. So we'll start by going over as to why VMware SRM and the storage array snapshot provides the best-in-class data protection and a DR solution for your business-critical Microsoft applications. Next, we will talk about the design and architecture best practices like as you're implementing the solution in the environment. So there are a set of storage and like also backup DR best practices that you have to follow. So we'll go over those. And the next, we'll talk about the failover workflows and also talk about all the special considerations that you have to make in terms of Active Directory DNS changes or managing the IP address changes across the sites. And then at the end, we have a demo in which we'll actually show you a SQL Server environment, and we'll do the storage array snapshots and do the failover of the environment with VMware SRM. Here are the key takeaways from the presentation. So the VMware SRM and the storage array snapshots provide you a fully automated DR and the data protection solution with the highest levels of RPO and RTO. And also, this solution can be implemented at a much reduced infrastructure cost as compared to a traditional DR solution for your Microsoft applitions. We actually did a joint reference architecture with VMware and Cisco, so it has a lot of useful information like the design architecture. So I would highly recommend that you take a look at the document. It's available for download on the NetApp site.
So I'm going to just give you a quick overview of Site Recovery Manager, what it does. Is anyone already using it today? SRM? Okay. Has anyone been in a session already today where they got kind of an overview of what SRM is? Okay. So this is a very short, very short overview. So Site Recovery Manager is a product from VMware that we integrate with. It's a software product you install at two different sites or two different locations. You have to have a vCenter server, a separate vCenter server at each site, and a separate SRM server at each site. So these are two independent VMware environments that you can fail over the virtual machines and storage in between the two environments. Between the two sites, you have to allow communication for the SnapMirror replication. That's the NetApp replication protocol. And also you have to enable for some either SSL or HTTP communication between the two SRM servers. The way the communication works in the environment is that if the SRM server at the production site needs to talk to the storage at the disaster recovery site, it doesn't talk directly to the storage. So you do not have to have like a firewall port open or something to let the SRM server from one site talk to the storage at another site. Instead, what it does is proxy all of its site-to-site commands between the two SRM servers. So if the SRM server at production needs to talk to the storage at the DR site, it will send those commands to the other SRM server, and that SRM server will make the communication. So those are the channels you would have to have open. So in general, SRM is a workflow automation tool. That's what it does. It allows you to automate the steps that you need to perform to recover virtual machines at the other site. And the reason this has value is because if you're automating things, there's less chance for mistake. It also keeps track of what you do. It allows you to perform tests for disaster recovery, keeps track of those, so you have audit logs so you can prove to people that you can recover the environment. So the way it kind of works in general is here it's labeled as the primary site. That's kind of a NetApp term, primary site, DR site. In case of SRM, they would be called the protected site and the recovery site. So at the primary protected site, virtual machines and their associated storage are collected into groups called protection groups. And then at the other sites, the DR site, you create recovery plans and put into those recovery plans the protection groups that were created at the other site. Then if a disaster occurs where the primary site were to fail, you can go into the SRM product and execute the failover and start up the virtual machines at the recovery site. It doesn't do this automatically. This is not an automated failover step. It automates the process of performing the failover, but it doesn't automatically trigger failover to happen if there's an outage or something like that at the production site. So in the solution that we're talking about in the session today, we use a combination of products. Here we have a Snap Manager products that we work with other vendors on development of. These are products that can give you some advanced backup features. Snap Manager for Virtual Infrastructure is a product that creates snapshots and backups of virtual machine instances on disk. And then we have application-specific backup products for Exchange, SQL, and Sharepoint that will do the same for the application data that's stored in those virtual machines. These products, the application-specific ones, give you the capability to do things like rolling logs forward when you do a recovery. So that means you can perform a recovery to some older snapshot and then roll the logs forward and apply transactions back into the database up to a certain point in time. So it gives you the capability to do point-in-time recovery to specific transactions and things like that, rather than just a single recovery to whatever you happen to last replicate. Another thing they'll do is automatic transaction log truncation. What that means is that they'll keep a log of the transactions that have happened in the database. Those logs don't just grow and grow forever and fill up your disk. They get committed to the database and moved and set aside so that you can perform those roll forward restores. They'll also do a backup verification. Once the backup image has been created on the NetApp storage, these software products will automatically mount that image and perform a verification against it. And it'll give you an indication in the GUI with a little green check mark that this backup has been verified and it's an application consistent backup. So you can be confident that it's recoverable. I actually kind of covered the granular recovery stuff. So we use the SnapMirror protocol for site-to-site replication. This protocol happens to support native on-the-box compression. So this is over the WAN compression. The data will be read from disk and then compressed as it's being read and sent across the WAN in a compressed format, and then uncompressed and written to disk at the other side. So if you combine this with the fact that you can dedupe the primary storage in a NetApp environment, you can get huge savings in the utilization on the WAN. So this is not on-disk compression. NetApp does have a feature where you can compress data on disk, but we didn't show that in this solution. This is just WAN compression. It's native on the box. You don't have to purchase a license for it or anything. It's part of SnapMirror. You just turn it on. So I mentioned that we have storage efficiency technologies on NetApp storage. We have the dedupe-aware SnapMirror compression. Building on top of this, when you perform a disaster recovery test with SRM, what will happen is you'll have replicas created of the storage objects at the disaster recovery site. These replicas are based on a technology called FlexClone. FlexClone will make a copy of an existing flexible volume on a NetApp storage array without requiring any additional space. So on a NetApp device, the volume is simply comprised of a set of metadata that defines the size of the flexible volume and whatever options happen to be set on it, like whether or not it's replicated. And then it's also comprised of whatever physical blocks of data happen to be owned by that flexible volume. So it's really a virtual storage device. What a FlexClone will do is create another set of metadata that says a flex volume exists. That metadata will point at the same blocks of data that the original volume is using. And you'll essentially have, when you view the storage, two copies of data with only 1x the use of space. And then this is given to the SRM product to use for disaster recovery testing. So in this little graphic, the gray area represents all the data that we've already replicated to the disaster recovery site. So this is all the VMX files, virtual disks, the SQL application data exchange and SharePoint and all of that. It's already been replicated. When you initiate the DR test, you'll use just a tiny bit of storage to create enough metadata to create whatever clones you need to use for DR testing. This literally would just be in the kilobytes or very small megabytes of size. And then as you run the disaster recovery test, you'll be booting up virtual machines. The virtual machines will use some capacity as they boot up, right? They're going to use their internal Windows page files. They're going to use virtual machine swap files. So you need to allocate for that in your environment. That's the maximum amount of space that you need to allocate for DR testing on NetApp is however much space you're going to generate when you actually run the test. You don't have to set aside a physical area of disk that your clones are going to exist in, or you don't have to set aside enough capacity to have a whole nother volume created. You don't have to have room for that. So what we have in this design is application virtual machine. It has its virtual disk that stores basically the C drive of the VM and the application and OS binaries. This virtual disk, in the case of a fiber channel solution, lives in a fiber channel VMFS data store. In this example, we've separated out some of the transient data that gets generated in a VMware environment onto a different data store that we don't replicate. The VM swap files get put onto a separate data store. You don't have to replicate that. You don't have to tell SRM that you're not replicating that. You don't have to do anything special to configure that or save that replication space. You can optionally put the page file from inside the guest operating system onto this data store. So what that means is you've gone into the Windows virtual machine, you've created another virtual disk, like maybe a D drive or an S drive, and you've configured it so that the Windows page file .sys file lives on that D drive, right? It's not in the C drive. Then, in that case, you store that virtual disk in a directory on this data store that you don't replicate with SnapMirror. And it's possible to configure SRM to handle that and automatically attach a different disk at the disaster recovery site so that you don't have to replicate that. But it's more administrative work to make that work. So it's possible to do. We've got a document that describes how to do that. But once you get into it, you might feel that it's not worth the administrative effort. It requires you to go into every virtual machine in SRM and make some settings in there to make that work. And then we have another flexible volume or set of flexible volumes that house the different parts of the database, logs, tempdb, systemdb, and that kind of thing. And these are all, in the case of Fibre Channel, these are Fibre Channel RDMs that store this data so that they can be managed. Actually, the creation of the snapshots is managed by the software that's installed inside the virtual machine, those application-specific Snap Manager products that I mentioned a minute ago. In the case of Ethernet storage, if you're using Ethernet, the layout's very similar. Application OS binaries can be in one data store. In this case, if it's Ethernet, you can put the OS binaries in VMFS iSCSI data store or in an NFS data store. And then the rest of the data the VM swap or other transient data can also be VMFS or NFS. The rest of the data, the application data that is managed by the Snap Manager products would live in iSCSI RDMs. And we recommend iSCSI RDMs in solutions that use SRM because an iSCSI RDM is actually connected to the ESX host. It's connected to the ESX host, and it's assigned to the virtual machine. The virtual machine owns the device, but the access to that device is routed through the ESX host. For that reason, when the SRM product interrogates the virtual center environment to discover the storage that you're using, SRM will be able to see that these virtual machines have iSCSI raw device map devices connected to them, and it will automatically include those in your recovery plan and your failover automating the connection of them to the virtual machine when they come up at the DR site. There's another technology that's actually pretty popular in NetApp environments, has been for a number of years. That's iSCSI, or what we call now in the VMware space, guest-connected storage. So that means that you're running the Microsoft iSCSI initiator inside the virtual machine, and from there, you're not talking to the VMware environment at all. You're talking directly to the storage array and mounting iSCSI LUNs there. It's possible to make that work in SRM with some pre or post scripting, maybe even ways to make it be automated by SRM with things that in SRM called callouts or command steps where it'll execute scripts for you. But SRM will not just out of the box connect guest-connected storage, because when it looks at the vCenter environment to inventory and check for what storage VMs are using, it doesn't see guest-connected storage because that's separate from the VMware environment. So we use SMBI to back up the OS Snap binaries, and then inside the virtual machines we use Snap Manager for SQL, Exchange, or SharePoint. So the way that kind of looks is like this, where we have the OS app binaries on VMFS or NFS data store. That's backed up with SMBI. And we have the application data in RDM LUNs backed up with the Snap Manager products. What the Snap Manager products will do is create a history of backups for you. You set up the schedule for how often you want it to back up. It'll create a full verified backup on whatever schedule you want, and then you can also schedule it to create just transaction log type backups, which are very small backups, don't consume much space. It's basically truncate. All it does is truncate the logs in the database and create a new snapshot on the storage array that uses almost no space whatsoever. You actually see later when Abhinav gives the demo, it just so happens in our lab, the snapshots aren't using any space because we didn't have a process that we would run between every snapshot to generate and fill data. So you can see that they all say that there's almost no space in there. So SnapMirror would replicate these backups to the recovery site. The entire history of backups is replicated to the other site. If you have a failure, you use the SRM product. You go into SRM and hit the big red button. They don't actually have a red button in there. It's a red click thing that you click on, and then you have to confirm that you're sure you want to perform a failover, and then make one more click, and it'll start running the recovery plan. So when you do this, you've failed over to the disaster recovery site, and then what we recommend you do is create another backup using the Snap Manager product at the recovery site and perform a verification of it. This is a way that you can feel comfortable, even though you've done the disaster recovery and you've walked away and you've gone home and everyone's at the disaster recovery site and they're working and keeping the business going. You still want to just make sure that you have a clean database at the recovery site and that you're not going to run into issues later. So without interrupting the production that you've established at the DR site, you can create another backup and have the Snap Manager product verify that backup. The whole time you're doing this, users have already been granted access to the email applications and the SQL databases, so you're generating data there. And you can continue with your backups after that. Whatever the backup schedule was before, it's going to keep doing that schedule. If the backup were to fail, if there's some corruption detected somewhere in the database, you can recover back to one of the other consistent backups that you replicated prior to failover. And if you've laid out your data in a way where you're following the best practices for the Snap Manager products, you'll have application data on certain storage objects and log data on different storage objects. And what that enables you to do is perform a restore back to a snapshot that you created before the failure, and then roll forward the new transactions that were created at the recovery site. So if a user logs into the recovery site after you've recovered, they send and receive some emails, they've got new emails in their inbox, and then maybe 4 hours later, whatever, you make this backup and it detects some corruption or something, you can restore back to a pre-failover snapshot, roll the logs forward, and when you let the users back in, those new emails that they sent and received are still there for them. so you don't experience loss. And I don't want to confuse you by saying you don't experience data loss. You don't experience any more data loss than what you've designed into your RPO, right? So if you have a 15-minute RPO and your failure happened 14 minutes after you last replicated, then those 14 minutes of data are gone forever. Right? So we're talking about data that you've newly written at the recovery site after the failover. And then the Snap Manager product will just keep making backups on the schedule. That gets replicated inside the virtual machine with the product. Okay, I'm going to let Abhinav do the rest.
Sure. So I'm going to. In terms of a successful failover of the environment and for the applications to continue to function, so you have to make some special considerations with the AD and DNS architecture in the environment. So the best practice recommendation is to have the AD and DNS servers at, say, both the primary site and at the DR site to provide the name, resolution, and the authentication services. And also both VMware and Microsoft recommend that you should not replicate your AD servers across the site. So by the replication, I mean that the backup and the replication of the backup data for the AD servers at the DR site. Because if you have a failure, right, and you try to recover your AD servers at the DR site, it could result in a failed recovery and have the USN rollbacks and the corruption of the AD databases. And then, especially some of your applications like Microsoft Exchange is extremely sensitive to AD. So you don't want that situation in the environment. Like you have a failure in the AD, and then your users won't be able to send or receive emails, or any of your application VMs like the Sharepoint or SQL are not going to be able to talk on the network. So the details of the issue and why you should not do that I describe in detail in the Microsoft KB mentioned here. And we also cover it in the details in the document that I mentioned earlier. So it's available on the NetApp site for download. So when you're doing the SRM DR testing, so when you do the test, right, so like all the VMs are powered on and are available in a private test network. So in that case, say in order to verify the functionality of your SharePoint, Exchange, or SQL, you need to have the AD DNS services available in your private DR test network. So, before you do a test, the SRM DR test, so make sure you make a clone of the AD server on the DR site prior to running the test, and then you connect the cloned AD server only to the private DR test network. So do not connect it onto the public networks. So once you do this, you will be able to verify the functionality of your applications in the DR test networks. And also another point to note is that if you are doing the DR test for Microsoft Exchange, so make sure you seize the 5 FSM roles on that AD server that just got cloned, like in the new VM. And those FSM roles are like read master, PDC emulator. So there is actually a list in the Microsoft KB mentioned there. And the detailed procedures on how to seize the FSM roles is also described in that Microsoft KB. Now, in case of a real failover, you do not have to make a clone of the VM. So the existing AD DNS servers at the DR site continue to provide the authentication and the name resolution services on the DR site. But if you have the Exchange environment, like Exchange applications on the VM, so in that case, you still have to seize the 5 FSM roles on the AD server. So let's briefly talk about like how to manage the IP address changes across the sites as you are failing over from the primary site onto the DR site. So there could be two scenarios. So the first scenario we have is a stressed VLAN. So in this case, the VMs are actually allowed to maintain the same IP address across, say, both the sites. You do a failover, so you don't have to change the IP addresses of the VMs. So in this case, as far as the SRM is concerned, so you do not have to change anything, right? So the only thing that you have to consider is that VMs are actually configured for multiple DNS servers across, say, both the sites. Because if your primary site is down, so the DNS servers on the primary site are going to be down as well. So after the failover, the VMs should be able to connect to some DNS AD servers. In the second scenario is the independent VLAN. So I've seen that in some customer environments. So both the sites are not allowed to maintain the same IP address. So say after I do a failover from the primary site onto the DR site, so I have to change the IP addresses of the VM. So with SRM, you make sure that for each of the VM, you enable the dynamic DNS update. So that way, once the VM powers on the other side, the DNS records are actually updated and your applications can continue to function. So a key point to note here is VMware actually provides a utility called the DR IP Customizer. So it's a utility and can be integrated into VMware SRM, right? So that way you create a spreadsheet of your IP addresses on the primary side and the corresponding IP addresses on the DR side, and then you feed that into the tool. So after the failover of your application VMs, so the DR IP Customizer is going to make sure that all the IP addresses are updated on the VMs on the DR side before the VMs are powered on and can actually continue to function. So all the details on how to do that are also described in the NetApp document that we mentioned earlier. So now I'm going to show you a video demo.
Do you want to? We're actually doing really good on time. Do you want to take a few questions? We forgot to mention earlier that we can take questions. Does anyone have anything right now? Yeah, that's okay.
For the replication time, for just doing the log backups, what's the smallest you've seen or what's the smallest you recommend? So what's the smallest RTO given that I have a large pipe to my site?
So you're saying if you're just performing, you're talking about site-to-site replication time, right? So when you do one of those transaction log backups, how long do we see the update take for those? It really depends.
How small can I make the window?
I think it's every hour, right?
Well, so I think that's what we have in the document is every hour, but it really depends on how much data, your database is writing. So you could do the math, figure out how much change you're putting into the NetApp storage array and how long it would take to replicate that. There's actually a command you can type on the NetApp controller called snap delta. And snap delta will tell you how much capacity you've used between two snapshots. So if you could run the Snap Manager product for a while, look at run the snap delta command and compare two of those transaction log snapshots. It'll tell you exactly how many kilobytes have changed between those two snapshots. To replicate that with Snap Mirror will take almost exactly that many kilobytes. So you divide that by your WAN speed and you can figure out how tiny you can make your RPOs. Yeah?
You mentioned you like RDMs better than the Microsoft SQL initiator. VMware seems to be pushing away from the RDM model. So
We,
do you have those scripts available to make the Microsoft SQL initiator work?
Actually, no. We don't have scripts to make guest-connected storage work. And it is true that more and more of what VMware does is not going to make use of RDMs. What I mean is, I don't mean to say they're not going to support RDMs. More and more of their products have no requirements for RDMs, right? And lots of vendors are doing the same thing, and we're doing the same thing as well. I'll just skip ahead. We have don't switch back. I'll go more detail later, but we're updating our software to support doing these things with virtual disk files, right? So when I say I like RDMs, that in the context of SRM, yes. In the context of outside of SRM, I'm not a fan of RDMs either, the same way VMware is not. We like RDMs with SRM because some of the NetApp products today require them. And if you use RDMs with SRM, then they get automatically detected and automatically attached, right? And going forward, we're trying to move to the virtual disk model as well. We've got some software coming for that I'll explain in a bit. Yeah.
She's actually talking about the failback.
Yeah, failing back to the primary. There's another session here that they've already both happened that talk about that. Basically, you reverse the roles of the two sites. The first few slides I showed that you have protection groups at one site, recovery plans at the other site. After your failover, while things are in production, it's not disruptive to production at the DR site. You can reverse the replication relationships and also reconfigure SRM to make this site the protected site and the other site the recovery site, and then use SRM as your tool to fail back, which is a good solution to do because then you also get to test your failback with the SRM test feature, and you don't have to like interrupt the production to do that. VMware is updating SRM to build in the capability automatically, so you can just from within the SRM GUI you can do everything. You can reverse the roles of the two sites. It's called the reprotect feature. It's being introduced in some of the sessions here this week, but it's still second half of next year, I think is what I've heard. I'm hearing SRM employees tell people second half of next year, so I don't think I'll get in trouble for telling you second half of next year, even though it's a VMware product and not NetApp. We don't control when it gets released. Yeah.
When you reverse it, SnapMirror back, is it just replication changes?
Yeah, it depends on the condition of the disaster. If the disaster didn't destroy your storage and you can bring your storage back online and bring it up with the data intact that was there, SnapMirror maintains a history of common replication points, and you'll reestablish the SnapMirror link, and it will find the last common replication point and only have to sync the deltas back. If it's the smoking hole scenario where you bought new storage, then there's no data there and you have to synchronize it all back.
So do you have a best practice recommendation? For example, up there you have SQL, Exchange, Sharepoint. From the storage standpoint, do you have a best practice recommendation for both the primary site and the replicated site as far as do you have a separate storage pool for Exchange, a separate one for logs, separate one for SQL databases, or you just make one big common pool?
In this solution, the solution we describe here and in the tech report, we use kind of conglomerated pools. So the entire Exchange environment is in one pool of storage that is kind of subdivided into some smaller pools where we do have logs and database on separate LUNs, but those LUNs are together in the same pool of storage, and they replicate together. It's done that way for each product. Sharepoint is in one, and you don't have to do it that way. You could lay out your pools however you want, but the pools of storage will be detected by SRM, and that will be the basis for your protection groups and recovery plans. So if you put your SQL servers into the same pools of storage as your Exchange servers, SRM is going to force you to fail those over together because they're replicated together. So you want to group things according to how you might recover them. We'll take one more and then we'll go.
If there is already a virtual infrastructure set up on the primary side and the other side, can you just add the SRM to an existing infrastructure, or is that something you have to do from the ground?
No.
The other follow-up question is if one is interested to do, Exchange, SharePoint tables, can you just give us an idea of what effort that is to get them set up?
Okay. So I have to apologize. I haven't been repeating the questions. I normally don't because I'm pretty verbose, people tell me. So I always feel like you're getting the idea of the question in the way I answer it. But the questions there were, if you have an existing environment set up, you're not using SRM, but you do have replication, can you add SRM to that environment and manage your failover? And the answer is yes, you can. All you'd have to do is go to VMware and buy the SRM licenses. The second part of the question was an idea of effort if you were setting up. Are you talking of setting up a new environment or taking an existing environment and deploying and adding SRM to it? Okay, so if you have an existing environment with these applications and you're adding SRM, the level of effort, well, we know this stuff pretty well, so for us it was pretty quick to do it in the lab. Do you have any idea? Because you were a NetApp customer and used, do you have an idea for like maybe number of weeks, how long it would take?
Yeah, it will depend on your type and the number of applications as well. Like say if you have a lot of the VMs and your volumes on the storage array, right? So in that case, so you need to come up with a plan and then like have the implementation strategy in place. So it could be anywhere from like a week to a month of effort. So it actually varies from environment to environment.
My question was specific to Exchange SharePoint.
Right. So in terms of Exchange, so if you have the primary site and your question is if it's already virtual or if it's a physical environment and you're planning to move to virtual. Okay. So if you already have the Exchange in the environment in say a VMware environment, right? So then like you just have to install the SRM software and you configure like all your relationships in say, SRM. So that would like only be a day or two worth of effort at the maximum.
And it's the same for each application. There's really no difference between the way the Exchange environment is configured versus SQL or SharePoint. Like we didn't have to, in the protection groups or the recovery plans, we didn't have to do certain steps for the Exchange servers and then different steps for the SQL servers. So once you figure out how to build the recovery process for one of these servers, that you just repeat that process for each and every server, and there's no step for each individual virtual machine. They're collected into groups by SRM, so you're failing over groups of storage. If you're migrating from non-virtual to virtual, NetApp actually makes that pretty easy. If you have a physical Exchange server today and you're connected with iSCSI or even Fiber Channel, it doesn't matter if you're connected with any block protocol, iSCSI, Fiber Channel, FCOE, or whatever, if you're connecting to the physical storage array from a physical Exchange server, you can shut that Exchange server down and connect a virtual machine to those exact same LUNs. You can convert them into RDMs. You don't really have to convert them. You just connect to them as RDMs. You'll actually see in the demo, if you notice it, I was hoping no one would because it's kind of an inconsistency, but all of these virtual machines are named _iSCSI because they are using iSCSI RDM devices. But when Abhinav opens the console of the SQL server, its name has _FC instead because it used to be the same exact LUN was connected with Fiber Channel, and we just disconnected from it with Fiber Channel and reconnected to it with iSCSI. So we basically, in a few hours, flipped all these virtual machines from being Fiber Channel connected to iSCSI connected so we could revalidate the same thing. Do you want to go on?
Yeah, I'd like to add that.
I'll catch up with you if you have a question.
Okay, sure.
Okay, go. All right, we'll go ahead now. Sometime this month. Yeah, I don't have the exact detail, but that's what I last heard. So, if it slips, we don't have disclaimers in our presentations, do we? Yeah, I'm making a disclaimer now. They didn't put one in the NetApp slide decks, but yeah, don't email me or call me if it doesn't happen, but it's coming very, very soon. We expect it.
So I'd like to add that, so in this environment, so most of the time is actually spent in making sure that the AD and the DNS actually works, like after you do the failover and also in the test environment. And also most of the time is spent on in making sure that your DR IP customizer tool is actually working and changing all the IP addresses across the sites. So those two are the most important and the complex pieces of the equation. So at this point, I'd like to show you a demo. So here we have an environment, and we have some Exchange, SQL, and SharePoint VMs. So this is the SRM protected site. So now, so we have the SQL VM. So in this demo, we'll actually do the backups of the database using the storage array snapshots, and then after that, we'll do a SRM failover, like a real failover simulating a disaster, and then we'll ensure that after the failover, the application continues to function and we are able to perform new backups. So the SRM relationships have already been configured in this environment. So this is the SRM recovery side. So once you configure the relationship, so on the SRM recovery side, it creates some placeholder VMs in the environment. So these are all the placeholder VMs for all the different applications that you see here. So now we'll go back to the primary site and we'll take a look at the SRM plugin. So this is the Site Recovery Manager plugin. So as you see here, so we have created the protection groups, say for each of the applications. So in this case, we have a protection group for Exchange, a protection group for SQL, and for SharePoint. And you see a list of the VMs as well in the protection group. So all the Exchange VMs in this case are in a single protection group. So that way, if there is a failure, so you don't have to like have your separate recovery plans for each of the Exchange VM. So everything is recovered at the same time. And this is the so next I will go into the DR site and look at the SRM plugin. The video is kind of cut on the top. Okay, so I'm on the DR site right now, and you see that the recovery plans have already been configured, say for each of the application. So once you have a failure, so you go into the vCenter server on your SRM recovery site, and you invoke the failover. So here is the recovery plan for SQL and for other applications. So next I'm going to RDP into the SQL server on the primary site, and we'll say create a new table to invoke some write operations in the database. So right now I'm creating a new table. Let's call it new table 1. Save it. So a new table has been created. So the next step in the process is, so I'm going to simulate a backup. So I'll actually perform the backup from the Snap Manager for SQL Server product. So this is this product is actually installed inside the VM. So this is the SQL Server instance here, and and the backups can be scheduled as well. In this case, I'm going to manually perform the backup. So if you see here, so I'm also going to initiate a SnapMirror update. So that way, the backups that you perform on the primary site are replicated onto the DR site as well. So here we'll actually see that like each of the step as you are performing the backup. So it ensures the VSS QSing of the applications as well, puts the database in hot backup mode. So now we see that the backup of the database has been completed in only a matter of a few minutes, and the backups have been replicated onto the DR site as well. So we will verify that in just a minute here. So this also ensured the verification of the database that got backed up. So now the next thing I'm going to show is the backup history. So so these are all the backups that we have in the environment. So on some of the backups you see a green check mark, and on some of the backups you see the amber question mark. So the green ones are actually telling you that okay, like all these backups are the verified backups. So after you did the backup, the verification of the database was successfully completed. So the backup that we just did is actually available at the bottom. So it was done back in March. So now we will go into the NetApp System Manager product that's used to manage the storage arrays, and we will verify the availability of the snapshots on the DR site. So before we do that, I want to highlight the SnapMirror compression that Larry talked about earlier. So in this example, we got extremely high compression ratios, 37:1. But it's going to vary from environment to environment, and then based on the data types as well. So we have a technical report that goes into the details of that.
Yeah. So our lab probably, super compresses because we populated, the table spaces mostly with like text data, which compresses very easily. The SnapMirror compression product is basically like a zip. It's almost the same exact technology. The data is kind of being zipped on the fly onto the wire and then unzipped at the other site. So you might have noticed sometimes when you zip a file that's all text. It'll zip down to like 50 to 1 or something.
So this is the NetApp System Manager product that you use to manage the storage arrays. So right now I'm looking at the backup history on the storage array on the DR side. As you see here, like all the previous backups and the backups that I just did have been replicated onto the DR side and are actually available on this site as well. So now the next thing that we'll do is we'll invoke the SRM failover, right? So right now I'm in the vCenter server on the DR side. So I'm in the SRM plugin. So there is a run button here. So as soon as I invoke the workflow is going to execute, and then it will make sure that all the SnapMirror relationships are broken, and it also ensures the network settings are set on the DR side, all the LUNs are connected, and also it ensures that the VMs are powered on and registered in the vCenter. So right now, so I'm seeing that the recovery has been successfully completed. So now the next step is, so I'm logging into the SQL Server VM on the DR side, right? So now this was actually a simulation. So the primary side is down. I went into the DR side and I did a failover of my SQL Server, and now my SQL VM is back up on the DR side. So now the first thing to do in here is, so we'll actually go into the management studio and try to see if the database can continue to function or not. So in this case, it's a simple example. So I'll go into the tables and I'll just add a new table in here. Call it table 2. So let's verify if the table can be successfully added. So as we see here right now, the table has been successfully added. And the next step is to go back into the Snap Manager for SQL Server and check the backup history from the primary site. So as we see here, like all the backups that we did on the primary site are now available on the DR site as well after the failover. So like if you have to go back in time, right? Say if I have to go back to say December 2009 and I want to restore something, so I can definitely do that in this case. So the next step I'm going to do is I'm going to invoke a new backup on this site to make sure that my Snap Manager for SQL Server can actually continue to function and take the snapshots of the SQL database on the DR side. So all the stuff we show here in the demo for SQL is applicable to Exchange and the Sharepoint environment as well. So you have to follow the same concepts, say for Exchange and SQL Server. There's no differences in the way that the backups and the replication work. So I'm taking a new backup right now while my VM is up and running and serving users on the DR side. So I've fast forward the video. So the backup is done now. So not only we have all the backups from the primary side, so we are able to create a new backup on the DR side as well. So if you see here at the bottom, I see a new backup at the bottom. And you see a question mark in here because for the sake of time, I did not do the verification of the backup. But in a production environment, you definitely make sure that you verify your backups. Okay, I think that's what we had for the demo. Any questions on the demo? Sure.
Yeah, so I get a little confused sometimes when they SnapMirror work. So you took a backup, you then initiated a SnapMirror.
Yep.
You then ran a failover when the primary site was up and running. So in the steps I understand is a crate kit does another SnapMirror sync as part of that failover process, right?
No.
On the storage?
No, you have to design, your RPO into the solution. Your RPO is based on the time between your SnapMirror updates between the two sites. Well, the site was actually up in the demo, the primary site, right? But there's nothing in SRM today that tells it to do another update before you fail over. That's one of the new features coming in the next release. It's called planned failover. and it will talk to the storage adapter and initiate an update during the failover process. But today it doesn't do that. So, yeah.
Is it possible to have two primary sites failing over to a single VR site?
Yeah, with SRM, sorry, I'm just making sure how much time we got. So we got 10 more minutes, so this is good. There's a feature in SRM called shared recovery site, and you basically have to have a vCenter server and an SRM server at every protected site, and then they can all fail back to the recovery site, a shared recovery site. That shared recovery site can have one vCenter server, but it has to have an SRM server for every protected site. Like different Active Directory domains? Yeah, I don't see why not, because the VMware environment itself, like the authentication you use to be able to administer the VMware environment, could be in one Active Directory domain. The Active Directory domains that are inside the virtual machines that are being recovered, SRM or vCenter doesn't care about, right? It doesn't talk into the VMs. Is that what you're saying? So you wouldn't be able to have one vCenter server at the shared recovery site that's part of multiple domains. That's just one Windows host, right? So I'm talking about inside the virtual machines, that could be different domains in there.
And if you can't fail over, like for Exchange specifically, you have to have a secondary mail record out that's got a higher weight on it to point to the new IP address of your recovery site. If you can't put the same IP address in your recovery site.
Right. So the question was, if the virtual machines have to change their IP addresses at the recovery site, do you have to do something with DNS or whatever for Exchange? The answer is yes, you do, or the Exchange MX records, they would have to be updated if the IP address changes. Now, in the document that Abhinav and I wrote, we tried to pick the most simplest and easiestly available technologies that are out there to fill each of the little gaps or administrative challenges you might have. So when Abhinav was talking about the IP address changing between the sites, you have to set up your environment in such a way that it's ready to be failed over with SRM. And what we mean by that is you have Active Directory servers at both sites, and they're on and active all the time, and they're being replicated with AD replication. You have DNS servers active at both sites, and you don't actually fail over the Active Directory servers. If the DNS servers are separate and don't serve Active Directory, you could fail those over, but normally you just have servers at the other site. And what I mean by having the VMs prepared to be failed over by SRM is that your environment's configured where somewhere down in the list of DNS servers are the DNS servers at the other site already, right? So when the virtual machine fails over, you don't have to go into it and tell it the new DNS servers. And this would be in a scenario where you're not changing IP addresses, right? So the virtual machine keeps the same IP address, but you want it to talk to its secondary or tertiary DNS server at the recovery site. Sorry. So in the case of changing IP addresses, the DRIP customizer utility from VMware not only changes the IP address of the virtual machine, but will also change its primary, secondary DNS server settings, its DNS domain name, however you want, whatever you want it to change. And then we also, in this solution, we use dynamic DNS. So the virtual machines will report to the DNS servers that their IPs have changed, and that's how the DNS update record gets changed in that case. But I don't recall us changing when we validated the IP address changing. Mm-hmm. I don't recall us changing an MX record in.
No, we do not have to change any record in Exchange.
Your MX record says you're at 20.10.
Mm-hmm.
To get mail to your 50.75 now, you have to have a secondary.
Did that get updated through dynamic DNS? It doesn't push the update.
Yeah, we actually had the dynamic DNS update in the VM configured, so that way it updated the DNS servers. So is that what you're looking for, or it's outside of that?
Yeah,
Yeah,
he's talking about the MX records that are in Exchange. So I believe we had it pre-configured with the secondary IP. But if you want to, I can give you my contact info and I can dig back into our lab to what we did.
Yeah, we actually had an Exchange expert as well who was involved in the project. So we can definitely get back to you if there were anything we had to change.
Just carrying on from that conversation, if I've got my primary site with, say, about 40 servers,
Right.
and I've failed them across to a secondary site, a VR site, which has got a different IP subnet. I've got 40 machines that I need to change the IP address on automatically. So I didn't want to use DHCP and dynamic DNS and all this sort of stuff. So I want to go through it manually. You mentioned the RIP tool.
Yeah.
Right.
What?
Does that require the machine to get switched on, or because my concern is to power on 40 machines, log in, change the IP address, shut them down, restart them again.
So the way the DRIP customizer works is that it's a utility that works specifically with SRM, so that SRM can automate the changing of the IP addresses. And VMware is improving this in their next release of SRM. They talk about it in some of the other sessions. They're improving the way it works today. So today it's kind of a manual process where you have to create a file ahead of time. And in this file you list an association of this virtual machine has this IP address at this site, but when it gets to that site, I want it to have a different IP address. At the production site, it has this primary DNS server. At the DR site, I want it to have this primary DNS server. So you build this association ahead of time. And then you create that file, you run the tool, the DRIP customizer utility. What that utility does is reads this text file, and it talks to vCenter, and it generates a vSphere customization spec for each virtual machine. And it stores that in the vCenter environment at the DR site. And then as SRM is booting up the virtual machines, it will apply the customization spec to each virtual machine as it's booting up.
So you should require a reboot?
It is not a super fast process because it has to boot the virtual machine up without letting it talk to the network because it has the wrong IP right now, running the customization spec inside of it, and then rebooting it one more time. That's what it does today. They're making it better in the next release.
What do you see people tend to implement in the real world if they've got large numbers of servers? Because having 40 servers can take about 5 to 10 minutes to do customization.
Right.
And you can quite easily run into 3 or 4 hours before the systems are actually workable.
Yeah. Yeah. Lots of the customers that I've happened to work with over the years actually have the same IP schemes at either site. Yeah, so it's just one reboot for each VM. So, and this is the reason the smoother execution of this process wasn't in the original SRM release because it wasn't a specific popular enough use case, right? So then shortly after 1.0 was released, they released the DRIP customizer because they got some requests for it. Now they're getting more, and they're making it more elegant in the next version. It won't use sysprep.
Yeah, I think we're running out of time, so you want to finish the last couple of...
Oh, sorry, man, I totally forgot we even had another slide. So here is the... Soon we're going to release the 6.3 version of the SnapBribe product. This is a product that will manage storage objects on the NetApp array. It's going to support you keeping your application data in virtual disk files in NFS data stores or VMFS data stores. And it'll give you the same functionality. Sorry, I should have said that wrong. It'll give you snapshot creation and management functionality on virtual disk files. It doesn't give you provisioning of virtual disk file capabilities because it's better and easier to add virtual disks to a virtual machine just using the vCenter tools that you have to go add more virtual disks. It's going to support SQL and Sharepoint in the initial release that comes out. We can't make some of the code magic that we need to work with virtual disks yet for Microsoft Exchange. So for the time being, for Exchange, you have to continue to do the iSCSI RDM thing. And it's going to require the Virtual Storage Console 2.0.1, which is a free product from NetApp that you install. It's a vCenter plugin that installs on your vCenter server, and you need that to make the virtual disk feature of SnapDrive work. There's a bunch more.
Yeah, one more.
SharePoint 2010, is that?
Yeah, so it's going to support all versions of SharePoint.
Okay. So this is our last slide if you want to note some of these resources. Any more questions? Yeah.
For small business, sometimes the non-effective as we are scientists and does SRM support 2 active sites and
Yeah. Yeah. I talk about that in the other SRM session I have here. You can have SnapMirror will let you replicate in both directions, different volumes in both directions. In SRM, the concept of a protection site and a recovery site is said all the time, but it's actually a protection group and a recovery plan. You can have at the other site protection groups and here recovery plans. So the notion of protection site and recovery site really applies within the group. It depends on what direction you're going. You can go in both directions. Yep. Okay. All right, cool. Oh, okay.
Can we take the questions outside, because I think there's another session.
Oh, they want to get us out of here.
Thanks a lot, guys. I appreciate it.
Thank you.